Every hydraulic machine relies on the pressure from a hydraulic fluid for their operation. The basic common component used in these machines that converts fluid pressure into linear actuated motion is the hydraulic cylinder. Today we will explore the components of hydraulic cylinder and understand its functional mechanisms. It consists of a cylindrical bore with an end cap. Its function is to hold the fluid pressure when oil is pumped into the cylinder. A cylinder head is attached to the other end of the barrel. It completes the enclosure to hold the fluid inside the system. A piston rod extends from inside the cylinder through the head. It transfers the force from the cylinder to the equipment on which the cylinder system is used. A piston is attached to the piston rod. It separates the cylinder bore into two compartments and reciprocates back and forth when the pressure is developed on any side of the cylinder chamber. A set of circular sealing rings are used in the interface of metals. These rings are assembled by making grooves in the metals. The seals used between the surface of metals in relative motion are dynamic seals, and those acting between two surfaces at rest with respect to each other are static seals. A piston seal acts as a pressure barrier between two chambers separated by a piston. The guide rings prevent metal-to-metal contact and resists radial forces acting in the cylinder. A wiper seal is used to wipe dirt from the rod while entering through the head and prevent contamination of oil. A rod guide ring is used to absorb transverse forces acting on the system and also prevents metal-to-metal contact of rod and cylinder head. A rod seal prevents the fluid from escaping the chamber. A buffer seal protects the main seal during peak pressures. A head static seal is used to seal the interface between cylinder head and cylinder barrel. Now let's understand the working of a hydraulic cylinder. The model shown here is a double-acting hydraulic cylinder, which means the system can extend or retract by using hydraulic fluid in both conditions. A hydraulic pump creates flow of hydraulic fluid into chamber CA. Since the chamber is confined, the fluid exerts pressure on all sides in the boundary of the chamber. When sufficient amount of pressure is developed, the piston is forced towards the chamber of low pressure. This also pushes the fluid back to the reservoir from chamber CB. The effective pressure that pushes the piston is the difference of pressure on the high-pressure chamber CA and that on the low-pressure chamber CB. But the pressure on chamber CB is almost zero compared to that in the chamber of CA. Then, force applied on the piston is pressure at chamber CA multiplied by area of piston. This is the force by which the piston and rod is pushed outwards. Similar principle is valid when fluid flows into chamber CB. But in this case, the effective area is the difference of cross-section area of piston to that of rod, because the fluid cannot exert pressure on the cross-section area of rod. This means the effective area in this case is less than that in the previous case. This is why the retracting force of hydraulic cylinder is always less than the force during extension stroke.